Okay, this video is over human mistakes and sources of error. Once again, a very specific, very short video because sometimes these can be very, very similar and these are very easily confused. So let's see if we can clarify things for you guys. Okay, human mistakes are almost always procedural errors, procedural mistakes. So the best way to do this is to always go back to the procedure and see if the procedure is followed. Step 1, Step 2, Step 3, Step 4. This is also going to be calculation mistakes. Things that you would normally say is like shake your head, smack your face on something that you just did that was kind of dumb. Little brain farts from time to time. Those are your mistakes. So for an example, the procedure says to measure 14 milliliters of water, and someone measures 15 milliliters of water. Obviously, that goes against the procedure. It's a calculation mistake. They went a little bit too far. They got lazy, so we can even add laziness to this as well. But those are your mistakes. Just simple little brain farts that can cause a whole experiment to go haywire. Sources of error, on the other hand, are limitations of the procedures. These are generally out of your control. Things that you could not have perfected any other way besides altering your environment. So some questions to ask yourself. Could the procedure be done more precisely? So measurements. This goes back to limitations of your glassware normally. A graduated cylinder versus a flask. A graduated cylinder is normally going to be more precise, but you only had a flask, so you were limited by what you had in your lab. Could it be done with less contamination? Is your filter good enough? Is your air filter in your room good enough? Were you wearing a mask? All those things that could have been prevented, but you were limited by what you had with you. Were the variables to be held constant, really held constant? Did the temperature change a lot? Did the air condition shut off overnight when you were leaving your petri dish over? Did it rain that day, and so the humidity changed inside the room? What assumptions would be made in collecting data? That's a kind of a difficult one. And is there a level of subjectivity in interpreting the data? Which means in your mind you really thought something was going to be a certain way. Somebody told you in the last class that this is what theirs turned out to be, so you wanted yours to turn out to be that way as well. So you were subjective to your results. You didn't actually interpret them right. That's still a source of error. You really can't control your mind and what goes in and what goes out. So now you've got 7 examples. So go ahead and pause it. Go through these examples and see if you can figure out, the example. Procedure states to measure 14 milliliters of water. They measured 14 milliliters of hot water one time and cold water another time. Remember, hot things are generally take up more space. The molecules moving faster. We'll get into that second semester, but that was a limitation, or a source of error. You can't control what comes out of the faucet, at least in our labs. Sometimes you can, but it's a good source of error right there. So now you've got 7 practice problems. Go ahead and pause it and run through these real quick. See how you are identifying mistakes which is a source of error. All right. Number 1, the student miscalculated the density. They miscalculated. Always a mistake. Anytime you do the wrong formula or punch the wrong numbers into a calculator, it's a mistake. The temperature of the room was assumed to be held constant. It's assumed to be held constant. You weren't here to control it, so it's a source of error. Transferring the powder from the weighing paper to the flask, a small amount of powder remains in the weighing paper. You're going to have that almost all the time. You can't control that to a great extent. You can control it a little bit, but it's a source of error. It's assumed you tried your hardest to get all that powder off. The student had used too much sodium chloride in HCl, so they used too much, had to start over. That's against the procedure, so that is a mistake. Student added the solutions in the wrong order. Obviously, again, we're against the procedure here, so that's going to be another mistake. Student compared the results of his hand-drawn graph and estimated the volume to be about 145. You estimated, you have a hand-drawn graph, so it's done by human means. That's just human error, so that's going to be a source of error. 20 drops of each solution were added to the reaction. You assume each drop's the same. It never is. It's not your fault. That's the dropper. There you go. That's another source of error. So I'm hoping you can see the differences here now. If you're thinking and you have a question, once again, come see us, and we'll do a lot more practice with this in class. And that's all for this one.